All right, but let's get started on time. And again, I'd like this to be an interactive session. Please feel free to ask questions, and let's kind of have some of the questions that are burning in your mind as you're looking at observability for the cloud, as well as for large-scale networks. So with that said, I'm Alolita Sharma. I am on the OpenTelemetry governance committee as a member, and also have been contributing and a maintainer on the project for the last 4 years. So really, pretty much have seen the evolution of OpenTelemetry as a massively popular project today. I also am a co-chair of the CNCF Technical Advisory Group, TAG, for observability. So lots of interesting discussions, as well as work that's happening in the observability space, as you know, in the CNCF. And I also lead Siri observability at Apple. So with that said, again, please feel free to ask questions as we go along, or we can take them at the end of the slides. But again, we have good time. So with that said, I think, again, thank you, Brad. Brad had a very good presentation yesterday on introducing some of the concepts in OTel. But let me ask, the folks who are here today, how many of you are using OpenTelemetry actively today or looking at it? That's cool. So many of you are already looking at it. How many of you care about observability in your systems, of your systems? Everyone does, right? So observability is an old concept, not new. It's been as long as there have been networks and systems, there has been monitoring. And monitoring, is one aspect of observability, but not the overall aspect. There is, collection, there's analysis, there's processing of data at scale, as well as visualization. So there's a lot of, detail, as well as, really finely nuanced steps that have been that is what describes the discipline of observability today. And OpenTelemetry is just kind of at that phase in its life as an open source project, where it has really hit the sweet spot, right? It's an open source system, as you know, and it is a new way of defining telemetry, at scale, which it collects all kinds of telemetry data, traces, metrics, logs, and enables you to really process that system behavior data at scale. So OpenTelemetry is a very interesting project because this really sets the trend or the norm, if you will, of modern open source projects, where you have the specification or the industry standard also being developed on the project itself, right? Which means that the OpenTelemetry observability specification is, really an industry standard for the requirements of what the components that the project is building. And the cool thing about this spec is, if you take a look at it, it's all open source. It's built in a collaborative way. There are discussions, there are design discussions, there are requirement discussions, and use case discussions on the project, which leads to the development of the spec. So you can see that whole design and requirements process on the project itself. It's not just building code, it's also actually building a specification. The second area, which is super interesting, from an open source project perspective, as well as from an observability point of view, is defining the data protocol, which is called OpenTelemetry Data Protocol. And it is a standard way of actually encoding and transporting data, right? So defining that protocol itself is also being done on the project. And that is also another aspect that is, again, has been happening in the new projects, but not so much in the past, right? You kind of have that transparency of the development, the thinking, the design, the requirements, everything happening on the project itself. The other aspects which are transformed into code components on the project are the instrumentation libraries, which are the APIs, SDKs, for instrumenting your applications, as well as the standalone collector agent, which exists, which is also a component that I'll be deep diving into. And then there are lots of other plugins, which are exporters, samplers, processors, different parts that I'll be walking through also. But the interesting part, again, to correlate back to the specification, is that the spec actually defines how these components work and what they do, right? And then it's implementation in code that you see in these components. So it's super cool to see that on a project of this size, and very useful to developers as well as end users. So OpenTelemetry is a very vibrant community today. You'd be amazed to see the kind of energy and the numbers of engineers who are working on this. It's the second most active project in the CNCF, in the cloud native space, right after Kubernetes. And how many of you are using Kubernetes today? Probably most of you, right? So OpenTelemetry is the second most active project in the CNCF space. It has more than 800 active developers at any given snapshot of time in this year, which is pretty phenomenal. I mean, 800 engineers working on a project is pretty significant. And the amazing part also is that there are about 175 organizations, active organizations, whether that's vendors or end users or other organizations who are interested in observability, who are actually working together on this project. And it really defines what the future of observability is going to look like, right? Because there's a lot of work that's happening in a collaborative way. To date, just, and OpenTelemetry is, I would say, a 4-year-old project, but also is a lot older because of Open Tracing and Open Census, which were the previous, generation projects that kind of merged together. And so to date, if you look at the commit history of the project, you've had more than 5,000 engineers work on the project, which is very significant, and almost 720 organizations. So pretty much, if you're working in the observability space or the Kubernetes space or in the container space, you have probably, submitted an issue or submitted a commit or a change, or reported a bug and have contributed to the project. Phenomenal amount of energy. The good news is that it's a healthy diversity because it's not only vendors, it's also end users, it's also individual developers, again, areas people who are subject matter experts in the area, all working together towards defining the spec, defining the semantic conventions, defining different aspects of the project before actually also writing the code. And just to call out loud, again, the project has a very healthy governance model, which is election of 1/3 of the GC happens every year. So if you're very active on the project or you're active maintainer or a contributor, you can get involved. It's a very open process. And this year, the elections were just held in October, where 43% of folks who were actually members of the project did vote. And I was reelected for the GC in October again. So just wanted to call that out because governance also matters on projects and sustainability and long-term health in terms of the technology being built itself. So I just wanted to call this out. This is something that is publicly posted by the CNCF. You might have seen the project growth charts, but you can see right after Kubernetes, OpenTelemetry is the second largest and most active project. So what's the value prop of OTel? Why do you care about this, right? I mean, why is everybody talking about OTel? OTel is today an example of what the future of observability is going to look like, because a lot of the work that is being done on this project really is commoditizing the nuts and bolts of observability or how observability solutions are built at scale. What does that mean? Many of you know that agent technology or agents themselves have been built in previous generations by companies who were APMs, vendors, or others, who were actually also providing a customized agent with their entire monitoring pipeline. Today, fast forward 5 years, you are seeing the commoditization of the agent. You're seeing the commoditization of the innards of observability at scale. And why does that, what the OTel kind of exemplifies that, because you have a standardized open source observability framework here with the requirements, with the specification, with all the moving parts, the data protocol, as well as the code all on the project. And all the vendors in the observability space, whether they are specialized observability vendors or APM vendors or even the large-scale cloud providers, are all involved in this project along with big end users as well as small, to be able to define the spec as to what works for the end users, right? And having a single set of APIs which are standardized, well-defined, having one agent and one preprocessor for being able to handle all types of telemetry data is pretty phenomenal in an open source project. Because what that does is it standardizes the technology that is being built and being integrated with something as major as Kubernetes, right? Because you can see that alignment where, like, for example, OpenTelemetry works very closely with the Kubernetes community and really is able to, kind of support the requirements that even the lower layer technologies such as the containerized platforms require. So the idea is that you instrument once, you instrument your applications once, and then you deploy everywhere, right? And that's pretty phenomenal because now you are fast forwarding to the future where you have a single agent being able to handle, in a very multifaceted way, all types of data for telemetry and understanding system behavior, and being able to deploy that, whether those are hardware systems or software systems or edge devices, any of these areas, it is something that you can just pick up and use. OpenTelemetry also is very interesting since it actually provides a foundational infrastructure for the automation of future smart systems. And the reason I say that is because as we have such complex networks of devices, systems, software and hardware that interconnect into what we monitor, including public cloud infrastructure, you want to have intelligent root cause analysis, right? How many of you use observability for root cause analysis? Probably many of you, right? But root cause analysis is very important because the sooner you can actually understand what the issues are and what you need to address in terms of, in terms of maintaining the health of systems, the smarter your systems become, right? And so it is a virtuous cycle there. And similarly, in the long run, the vision is that can you use observability as well as fundamental components such as OpenTelemetry towards building self-healing, self-learning, self-evolving systems. Because at the end of the day, you really want to see as much automation as possible at scale where you're managing millions of devices or millions of systems in a network, right? Millions or billions. And data, which is petabytes of data coming in at a very high volume from so many devices across your network. So that scale can only be handled by automation. That scale can only be handled by intelligent, smart systems. And ideally, that's what OpenTelemetry's promise is, where you move towards commoditizing those components at scale so that you can actually focus your systems to be intelligent, understand your data well, and understand how your systems operate. So that said, I just wanted to give a quick run through of where the components that are being built on the project are today. The good news is that, as you can see, the specification as well as the data protocol OTLP are stable. the collector, which is the collector agent, as I highlighted earlier, as well as the 11 languages in which the APIs and SDKs are available for client instrumentation. Traces is pretty much stable. Metrics is in progress. Metrics is stable on the project because the specification, the data protocol, as well as the implementation on the collector and most of the major APIs and in the languages is stable, like Java, JavaScript, .NET, Python, C++. So these are all stable. And then Go, as well as some of the other languages, are in development right now. Now this also fast forward to logs, which is, in one sense, one of the most mature in the industry, is in development. And logs got picked up, after metrics. So it's in progress right now. We expect it to be stable by the middle of next year. But I think it also shows that, the project came in with a lot of engineers who were experts in tracing, experts in metrics, and now, are kind of also pulling in. And this is a great time to get involved if you're a logging expert or have worked on logs in different languages. Great time to get involved with the project and be able to contribute there. But it really is, again, depending on the subject matter expertise of the contributors who are working on the project, as well as, some of the foundational specification work that is also ongoing. The interesting thing about this also is that, for example, there are common schemas that are available in logging, such as ECS, which is the Elastic Common Schema that's used a lot in logging as just an ad hoc standard. And other industry standards are also being incorporated into the specification for OpenTelemetry, which makes it interoperable, right? And that's part of the reason why the specification is still in development, because those discussions are still ongoing on the project in terms of making sure that that there is full interoperability with existing industry ad hoc standards. All right, so moving on, I want to kind of pivot into the architecture of the project, which is really the heart of OpenTelemetry in my talk today. Want to talk a little bit about the overall workflow of how OpenTelemetry works in an observability pipeline. And as you can see, there are client components in an, from which, think of it as three parts, right? You have data sources from which you're collecting data. You're processing it on the OpenTelemetry components, as well as exporting it then to backend storage systems, which are helping you analyze at scale, as well as visualize, right? So on the left-hand side, you have microservices, client instrumentation, as well as shared infra, which are kind of three layers of a typical system. And the client instrumentation, which is kind of at the bottom here, but could be on the left-hand side, really demonstrates the data sources that you are, or your applications that you're instrumenting with OpenTelemetry APIs and SDKs to be able to collect data, right? And generate your traces, generate your metrics, generate your logs, and be able to, kind of ingest that. Microservices is a second category. That is, if you're running any kind of services, which are application services, you can also instrument those, such as databases, other kinds of security components, or any other kind of search services. You can instrument those with OpenTelemetry APIs, and then be able to also send, push your metrics to OpenTelemetry or pull. And third but not least, the lower layers, where there is the cloud infrastructure. You have typically Kubernetes sitting at that layer, or other virtualization implementations. You have proxies, you have other networking components, as well as you could have shared infrastructure coming in from public cloud vendors, where you can actually collect, instrument those and collect that natively, that data, telemetry data natively, to be then received by the collector and processed further. So just wanted to kind of call that out as a key area, because gathering, collection efficiently and optimizing that whole pipeline, and being able to scale that is one of OpenTelemetry's main focus areas. The second part to really consider here is what does the OpenTelemetry Collector do, and I will be diving into that a fair bit right after. And then being able to analyze and process that data in order to send it to a data storage. It could be a time series database, such as Prometheus for storage, and it could be a trace database. It could be a column store for logging, right? So moving on, again, I want to kind of touch upon the components and then dive into the collector. So the client, as I had mentioned earlier, consists of a whole bunch of components, right? So there are 11 languages, that OpenTelemetry actually supports, which is pretty phenomenal for a project. And out of that, in these client instrumentation libraries basically talk to your applications, whether those are client components or services, right? And that consists of the API, the OpenTelemetry API, the SDK, which is separate from the API, the plugins for SDKs to be able to receive and send data to the collector, as well as the auto instrumentation or the instrumentation libraries. And that fundamentally is where the clients feed into the OpenTelemetry Collector, and it enables the application's interface, for being able to ingest data into the observability system that you have. So as I said, the API is explicitly separated, and this was a design decision made by the project, where the API is, again, disconnected from the implementation, and it really optimizes, like dependency management, right? Because if you don't have certain dependencies available in the system, then it's only your API that is binding with the application. It doesn't carry the load of the entire SDK until runtime, right? So it provides for extensibility and flexibility in the implementation of your observability pipeline, as well as reduces dependency conflicts. So when you're running, say, through your CI/CD observability workflows, for example, if a dependency is not found, it will ignore and move on rather than, kind of just failing. Also wanted to call out that there is a plethora of 11 languages here. If you see there's a language missing here, feel free to make an OpenTelemetry proposal. And again, there are communities of languages very active on the project. So if you're missing a language here, please, don't hesitate. It's a very open process. You say, hey, I need a binding for this language, and it's not available here, Haskell, for example, or others. You can actually make a proposal on the project itself in the community repo, and it's called an OpenTelemetry enhancement proposal as an OTEP, just like very similar to what Kubernetes does with the Kubernetes enhancement proposals. And you can just file that and say, hey, this is why I need it. And typically, the community will say, okay, so how do we do this? What's a use case? And go from there. So just wanted to call that out, that it's very easy to get involved in the project. And one of the key ways that many of the new contributors get involved is because you're good at a particular language, or you have a use case for a particular language where you want to kind of see an API and an SDK being built for it. All right, so moving on to the collector, which is the focus of today's discussion. The collector is really the heart of OpenTelemetry. And it is also the most complex component of OpenTelemetry. It has several subcomponents within it. And it enables applications to be able to ingest the data and then be able to pump that data to back-end storage systems for analysis and visualization, and also to be able to be adapted very easily because it is an super modular component to support use cases such as security, such as self-healing, in the long run, self-evolving systems. So the design is very, very flexible and extensible for the collector to enable that kind of extensibility in the long run. So it is, built for future proofing. And it's reasonably future-proofed because, that's how it's designed today. The collector is written in Go. So for many of you who loves Go here? Some of you do. I know many of us have done Java first, and Go is kind of the language or the lingua franca, if you will, of observability today. But that said, Go is easy to learn. All right, so let's get into the workflows here, and I'll walk through a couple of observability workflows. Many of you who may have looked at the documentation on the project may have seen an version of this workflow. But as you can see here, the project actually has made a commitment towards interoperability. The day OpenTelemetry was created, it had a fundamental promise to the community that it will support some of the ad hoc standards that exist in the industry, such as Jaeger and Zipkin for tracing, Prometheus and StatsD for metrics, right? And because of that, you see that OTLP, which is the native protocol of data protocol for OpenTelemetry, as well as Jaeger, Zipkin, Prometheus, StatsD are fully supported in the core collector workflow. And that's very fundamental to understand because, if you're building out an observability pipeline, you typically will have, Jaeger, Zipkin, if you have used, been doing tracing, or if you have metrics, Prometheus or StatsD, it's typically running in your system. And that interoperability was built day one in order to guarantee that if you have existing services where you're using Jaeger or Zipkin for tracing or Prometheus or StatsD for metrics, that will also be usable out of the box. All you need to do is add it to your configurations, and it says you can just pick it up and run. So here you can look at the color-coded errors, but you can see that OTLP today, which is the native protocol, handles traces and metrics, as I showed you on the previous project status. Traces and metrics is stable, so hence I've called that out. But logs and profiles are the other two telemetry types that are coming in. So that's something that you'll see those errors also join in the next few months as they're stable and they can be fully consumable. Logs you can still send today. It is available as functionality in the collector, so don't be shy. You absolutely can be alpha beta users for the collector today, and that functionality exists. But you can see that OTLP can handle traces and metrics out of the box. If you're using a Jaeger data source, you can actually send data, traces, and the OpenTelemetry receiver, collector receivers can just ingest that out of the box. There is a concept of processors in the as another component, and I'll kind of deep dive into this as a follow-up, is where you have the collector, which has foundationally three types of components, right? Receiving for receivers and ingesting data, processors for pre-processing and analyzing, aggregating the data, if you will, and then making it ready for export to a data storage. Okay, so these are kind of the internals of the collector itself in general. Now, I know that Brad had gone through the some of the list of the processors as well as the exporters and receivers in his talk yesterday, so catch up on his talk. But there are, a plethora of receivers as well as exporters already available in the OpenTelemetry Collector repos. And if there's an exporter missing, that is you're using a backend where you're sending your data to, feel free to, again, file an OTEP that, hey, I'd like to see this exporter. Is this something that, someone is working on, or can I actually work and provide a design for it? Right, so again, please take a look. I wanted to call out, the batch and attribute processors here because they are pretty standard for traces. And they're typically used for, adding attributes for your telemetry traces. And batch is usually if you're chunking a lot of data and sending it through, right? So these processors are pretty common for tracing pipelines. And then you have batch and filter processors for metrics, which is, again, part of the core. And as I said, you have logs and profiles where there's a lot of work that's happening, development that's in progress on the project itself. So if you're interested in profiling, for example, specifically kernel profiling or any other kind of network profiling, it's a good time to get involved in the project. All right, so zooming in further into the collector and the innards of the collector, if you will. These are the core components of the internals of the collector. That is the collector core, right? And then there are a whole bunch of exporters and receivers that you can find in other types of customized observability pipelines you want to build, which is in collector contrib. So I've given the GitHub repos on the bottom, and you can go and check out these GitHub repos for the other modules. But this is the core. So why I call this out is that, as I said, OTLP with HTTP and gRPC is foundationally supported out of the box. That's the native protocol. And you can see both for the receivers as well as the exporters that those components are available. For traces, again, the Jaeger and Zipkin are part of the receivers. And then also there are individual exporters for each one of those. And then for metrics, as I said, Prometheus and StatSD. This is the promise of OpenTelemetry to maintain interoperability with all the data protocols and the data formats of these open source systems. The processors, as I said, the two foundational processors which come in as part of the core collector are the batch processor and the memory limiter. And then the rest can be added on, right? Like if you're looking at host metrics, you can add on another processor, for example. Or if you're looking specifically at Kubernetes, you can also add that on. So there are other components that you can just add in, but this is the baseline. That is, if you were to go and download the release of the collector core, this is what you get. The other core modules, which kind of do all the chunking and the engine actually of the collector, are these components: the client, command modules, the component modules, config map, consumer, internal, extensions, pdata, ops report for and services. So these are all the modules in the core of the collector, and these kind of chunk through all the protobuf data that you're sending, examining it, and aggregating it, being able to process it, and then send it. Feature gates is an interesting temporary feature right now, and this is to again enable compatibility in the short run while the metrics implementation in Go is getting completed. And in the long run, the idea is, because the Go SDK is also, and the collector are both written in Go, that there will be a common module which will be shared by the Go SDK as well as by the collector, which contains the common internals for both, right? So it's, again, feature gates is just an feature flag kind of an implementation. It's a very thin shim until the main component, which is being built as a common module, is completed. So I just wanted to call that out, that it's temporary, and it'll change. So any questions on the collector internals? I mean, I'll move on, and if you have any burning questions right now, happy to take them. All right, moving on. So the OpenTelemetry protocol, which is the data protocol, defines the, again, as I said, the encoding of the telemetry data itself. And it is defined on the project. It's pretty stable at this point for the 3 telemetry signals, which is metrics, traces, and logs. But there is a lot of work which is ongoing on profiling and profiles, as well as other telemetry signals that are being looked at, such as events, right? So, if you're, for example, when you're handling edge devices or IoT devices, events, or web browsers for that matter, or mobile devices, right? Events become a major part of the telemetry that you are collecting. So a lot of work that is ongoing is about events and profiles right now, and that will also get added to the protocol. So for the 3 major signals that I talked about just now, that OTLP is stable, but then there's more happening which will get added to the specification as well as the protocol in terms of definition of how events are handled and how profiles are handled. So that's coming soon. As I also said earlier, OTLP is implemented through over gRPC as well as HTTP as transport layer. And it uses protobuf, which is very common as an implementation in Go for serializing data payloads. So just wanted to call that out. And if you want to look at the protocol specification that's published on the project itself, please feel free to kind of dive in. It really outlines in detail how do you do send requests, how do you do receives, transmits, errors, any kind of protocol exchange that is happening at the data layer itself. And this is very important because you do want to understand how your data is being shipped, especially if you're adding custom exporters or any kind of integrations that you're doing for your observability services. Last but not least, I'd like to call out that there is actually a playground on the OpenTelemetry project which you can actually go and use. It's called the OpenTelemetry Demo. It enables you to actually use OpenTelemetry for different types of observability pipelines. You can configure it, you can set it up, you can run with it, and there is, you can take code from this where there's an end-to-end observability solution that you can just pick up along with the instrumentation for traces and metrics. And this is super useful because you don't have to build your own pipeline. You can just take this as a baseline with the configurations for the instrumentation that you need in a particular language. And the 10 of the OpenTelemetry language SDKs are already built into this demo code, so you can take that and run with. There are also functionality for creating custom spans for tracing, as well as getting more detailed spans and traces for using auto instrumentation. For example, Java and Python have auto instrumentation, so you can go and run with that and just use it out of the box. You can also have context propagation that is built into this demo that you can just take out of the box and just run with and set it up. There are Dockerized containers that are also available for these configurations, so you can just take the Dockerized image and just use that. There's also metrics fully implemented in this whole demo, and so that you can take observability data attributes which are defined very clearly between services and be able to pass that context as well as baggage if you have specifics defined for your application, as well as you can define other attributes, events, telemetry data that you might have for your application very specifically that you might be passing. It could be security parameters, it could be other custom attributes that you have for your application that you're passing across the services and then to the data sink. So just wanted to call that out, and there's an extensive amount of documentation. This is a very live project within the project itself, and if you see a backend not supported that you'd like to see, please just ask for it, because it's work in progress and somebody will come and build it. And if not, even you can. So that said, I'd really like to request everybody to, who's interested, to get involved. It's very easy to get involved in the project. That's been, a major part of the success of OpenTelemetry. It has an amazing community. The different SIGs, which are specialized on different topics, meet every week online on Zoom calls. And the calendar for these meetings is published on the CNCF calendar. So if you're looking to join in for a discussion, you can. It's as simple as just asking your question in these meetings. The maintainers join in. They can answer any of your questions. If you are looking at any particular configuration, you can share it, that, hey, what am I doing wrong? And it can be any people come all the time to come and ask. There are also the CNCF Slack channels. If you are not familiar with them, again, please join the CNCF workspace on Slack. And OTEL has a whole bunch of channels because of specialized topics and language-specific channels which you can come and join in. And again, this is the code. OpenTelemetry is the org. You'll see at least 30 repos, if not more, of different components, as well as the project documentation. So that said, I just wanted to kind of touch through the core internals of the of the collector, but there's also a lot happening, and there's a great opportunity to get involved. With that, thank you, and happy to take questions.